Hello everyone, welcome to all of you in this video. So today's in this video, I'm going to talk about the linked list data structure. What is linked list data structure? What are the real life applications? And I will also show you and I will make the programs of linked list data structure. And I will implement all the traverse insertions and deletions of the linked list. And I will also write the programs to find out the length of the linked list. Okay. So first of all, let me tell you about the linked list. What is the linked list is all about? Linked list is nothing but it is a types of data structure. Means it is a linear types of data structure. Actually, there are two types of data structure: linear data structure and non-linear data structure. In the linear data structure, it is linked list and just take and cubes comes. But in nonlinear graphs, trees, these are the nonlinear data structure. So what is linked list? Linked list is nothing but it is a collection of list nodes, right? So actually, linked list is a collection of list nodes, and each list nodes contains the data and reference to the next list nodes. Reference means address of next list nodes, and on the basis of that address, they connect together. They connect with each other, and they make one kind of chain and represent the whole data structure. Okay, let me tell you the difference between array and linked list. Arrays are also linear data structures, and linked list are also linear data structure. Both the data structures, both are the linear data structure, right? So what is the difference between arrays and linked list? Arrays, the difference between arrays and linked list, arrays only store the data and they have the address. But in linked list, they do two things. One is store the data and also store the address of next, means next nodes, address of next list nodes. So this is the difference between the array and linked list. And array have so many limitations because if we are having the memory, right? Basically, there are two types of memory. Contiguous memory and fragmentation memory. Means contiguous memory means inside the memory there are the there are the spaces where we can store the data in continuous way. Means contiguous way means in one single lines. But if we have the fragmented memory, means we are having the some spaces somewhere, and somewhere means we are having the distributed space. So in that case, we can use the linked list data structure. So it helps to manage the memory parts, right? So this is the main advantage of linked list data structure, and other so many advantages. And we can use the linked list data structure. So to create the playlist of music, we are using the linked list data structure. So these are the simple basic applications. And another thing is that to create the load balancer, also we are using the linked list data structure. So okay, this was the applications and introductions of linked list data structure. So let's do the program. So let's start. So first of all, we have to create the class node. Inside the class, we are going to create the constructor self. We are having the one node contains two data. So initially we skip value data as a node, and then next to restore the address of the next list node, skip this value also node. Self dot data equal to data, self dot next equal to next. Okay, so this is the constructor. Okay, then after make another method get data. Sorry, first set data, then get data. Set data. So it helps to set the data. You're going to take the data as an argument. Self dot data equal to data, and next method is get data. Self to get data, we just need self dot data return. Okay. Returning the value, right? To get the data. So another method set next, self next, self dot next equal to next. Okay, one more. Get next self return self dot next. So self is about, I think about the class. Self is a keyword used in class to bind the methods. Okay, and so many definitions of self. So okay, self work as a pointer. Fine. So we have created the class of node, and then after we will create the objects of node class, and we are actually indirectly assigning the value to the node list nodes. Okay, so first head node. Let's say one node one. Okay, two node two equal to three. Node 3 equal to node 4. Node 5 equal to node 5. Okay, sorry, not 3 equal to 4. 5. So till now just skip this much. Okay, and create the link is here. Connect the head with set next with node 1. Head set next with node 2. Sorry, we should write the node 1 because we are just making the link is. Then after node 2 dot set next node 2, sorry, node 3, yeah, we should write node 3. Now the last one, what is the last one? Node 3 node set next node 4. Now we don't have other nodes, so just we have made the link is among the nodes. Okay, then just run this program. So now let's see, now the link list has been created. Now we have to traverse the link list, right? So we have to write the traverse functions. Okay, we are just passing the head to traverse. So what we will do here is store the value of head at temp first, and then after while temp means while temp equal to node null, then just execute these functions. So inside the functions, what I'm going to do here, I'm going to print the temp dot get data. Okay, and to print it horizontally, so right like this is just like decorations, like how to print. And then after we are just jumping to the next node. Okay, temp dot and get next, right. And then finally after the value of temp, if does not equal to none, then the loop continue working. If equal to none, then terminate the loop and we'll return. Okay, so okay, so we'll no need to return because I have already printed here. Now it's done. So I have to pass the call the functions by passing here. See 1 2 3 4 5. 1 2 3 4 5. This much value I have linked it. So this is actually linked list. This is the linked list. Linked list. Okay. Now just let me write the recursively functions to traverse the list linked list. So traverse recursive functions. Okay. Just pass the head to the traverse. Then if not head. Okay. So write here node because for head is also one types of node. So above we also can write nodes, no problems. If not node, then we just return. Else what we'll do? Else we will print. Okay. We'll print. What will print? Node dot get data. Okay, comma, and so I will print this in this way, and I will call the functions. I will pass node dot get next. Okay, so execute it, then call the functions traversal and pass the head. So I'll get again the same value. Okay, now next, how to find the length of the linked list. So write the functions to find the length of the linked list. I'm writing the functions length. Okay, so just I'm simple functions length linked list. I'm writing the simple functions. So first, what I'm going to do, I pass the head, and it is the same like we have to write the one extra variable count. Okay, so first store the head in temp, and then after make extra variable I equal to, let's say, sorry, no, length, right. I have to find the length equal to, let's say, initially 0. Okay, while temp increase the length plus equal to 1, and then after we'll just update the temp dot with get next, right. Then after we return the length. Okay, let's run these functions and call the functions. Is it right or wrong? Yeah, I'm getting value 5. Okay, if I will just add here one more node 5. Okay, node 6, and then again here node 4 dot set next, node 5. Then see, initial length was 5, now it becomes 6. Okay, so now find the length by recursive way. Okay, so length list redirect, pass the head, no right node here, like it is easy. If not node, then return 0. Okay, else return 1 plus length list rec, call the recursive functions dot get next, find. Okay, let's call these functions again, length rec, pass the head, get the output. Okay, now write for insertion linked list. So what we have to write the head and data and at which positions we are going to insert k. Okay, so instead write the invalid conditions. Invalid condition. What should be the invalid conditions? If k less than 0 or k greater than length list head, the conditions print invalid input. Just terminate the loop, return head. Okay, if k equal to 0, so it means that we have to insert at the first positions at these conditions. So before that we have to create the new list node, right. So new node equal to node and data. Okay, so then after, what we are going to do, we are going to new node dot set next here, and we are going to make here as a new node. Fine. Else we are going to make one variable. So we are going to store the here value, and then after one variable again to count how many list node while I less than k minus 1. What will be these conditions? So then previous equal to previous my dot get next. Okay, I'm going to increment the value of I by 1, and then after you're going to set the new next node with previous dot get next. Last node means new node of previous new node after coming node we are going to add. Then after we're going to connect new node with previous one dot set next with new node. Okay, and last we are returning the value inside, returning the head. Then let's call the function and is it work or not. Insertion list head and data is equal to, let's say, 14. That means positions we have 6 already, right. So inserted 6 positions. Now I think it's inserted, and now find the traverse here. See, the 14 is inserted at last. Okay, it's at 2 pens. Yeah, done. So we can change the value like whatever we want. See, value is setting. Now last one is deletions. Okay, So deletion node. So you're passing the here and positions, which positions we want to be there. So I'm the invalid condition. Distance. If k is less than equal to 0 or k is greater than equal to length linked list, the conditions print invalid put k return there. If k equal to 0, what we're going to do, we're going to make here as a next head dot set next. Okay, head dot set next. Head dot set next and get next. Set the get next. We have assigning the value of next value to the making a second node. We are making as a head. Else conditions. Return. Okay. Prime equal to head. I equal to 0 and then write the conditions while I less than equal to k minus 1 pre equal to previous dot get next I equal to 1 then after we just previous dot get next previous dot set next previous dot set next equal to previous dot get next dot get next means we are jumping to a step and we're jumping to a step and removing in between. Okay, and finally return here. Done. Let's see deletions or not deletion or is it right or wrong. So I'm having here as a head and for positions I'm passing 1 2 3 4 5 6 7 8 9 10 1 2 3 4 5 I'm deleting 5 so that's why I will find the 5 positions. Okay, now then after I have to traverse. Okay, sorry, after it I'm writing this code as here head uh, let me run again. Okay, it's deleting means 14 deleting means okay means 5 means 1 2 3 4 5 means after 5 14 is deleting. Yeah, okay, got it. So this is the deletion code and okay fine. So that's it for today. Thank you so much for watching video.